Right, so we're doing some pendulum control today. Let's get going. So I've been writing this auto differentiation framework in C because C is best language. And one of the cool stuff here is that we can do machine learning, which is cool, but we can also do pendulums, which is cooler. So here we go. So this is fine, but I'll tell you in a minute why it's not best. So we can do a lot better, and we'll try and make it nicer. So, oops. Cool. Step one. Let's figure out what this does. Yeah. So we'll take this. We've got ourselves a pendulum, right? And we've got like here, and then it has a attachment. That's good enough. And we've got some states. It's got like an angle and a velocity. So like the angle is measuring basically that here. This is 0 pointing down, and what we want to do is we want to move it. So we have some controls that are applied to just one dimension, and every time step, what we do is we take this position and velocity, and we move them a little bit move them a little bit forward. So like we start at 0, and let's say we give it like a 5, and you'll see here we've coded this here. So our little u gets affected by gravity in some way depending on our position, and then that gets added to our x's, and realistically, that's not what I want. X1 then is going to be like this plus our velocity times some time step. So this is how you move. You're moving by a little bit, and then you times that by how long time takes. So like dt is, in my case, could be like 0.1, and then we're moving this a little bit, and then also this thing gets moved by its derivative times dt squared. And this is cool. And what we can do is we can code this into this library that I wrote. So we've got a lot of functions here that we imported, and this really just lets us do control in a minute. So here's my state, and I start at 0, 0 here. I start up here at 0, 0, and all of these are wrappers around the library. So the nodes are nodes in the graph. I'll show that in a minute. And then the tensors are just tensors, like PyTorch tensors, but we wrote them from scratch last week. And then this is how we integrate the state and time. But let's just simulate our physics. It's pretty cool. We start at 0, and those are our u's. And then every time step, we just basically call this f, and that gives us the next state. And then we just add that to the list of states. So if you run this, this is just me doing terrible math. Here, what we'll see is that we've got a bunch of zeros because we're not actually moving the pendulum, and then our u's are also zeros. So I could like make our u's something like 2, and then u's are going to be 2 because I made them a constant, and then the x's are going to move. But actually, for the x's to move, I need to call this function, which is going to do the forward integration, the last state, like that. Yeah. Ooh, I segfaulted. Lovely. That happens because we wrote our own auto differentiation library. Funny. But the idea is that once you move these things forward, you can effectively move the pendulum up. This has really crushed it, hasn't it? Nice. Okay, so we've got our x's, and we're going to go forward on this. So then our axes are gonna start moving up a little bit. And the point is that we can then make our own control problem by defining where we want to be at the end. So what we're going to have is we're going to have a bunch of x's and y's. Where's my text? There we go. So we've got x and x0, got x1, and so on. And I've got a list of these. And then I've got my my controls, and these go to one less. So like this. Nice. And then I'm trying to swing this thing all the way up here. So we start at 0, and we want to get to to pi. And so the thing is, and we want to also stop it, so we don't want it to be swinging like crazy and then keep going. So we want to swing here and then decelerate a little bit and then stop at the top. So kind of like this figure here at the bottom. So I've got this here, it starts and then it slows down a little bit, and then hopefully it stops there. Right, so it doesn't just like go crazy. So what we do is we take a target node here, and I'm saying here I want to be a pi, I want to be upright. And then we have some weights. We'll get to the weights in the limits. And I'm saying I want to be here, and this is the distance between me and like the last state, the -1, and where I want to be. And then this is squared because otherwise it can be negative. And then I do exactly the same thing for my velocity, and I want this to be 0. So basically this is the same as saying anything other than 0 is bad. And then we'll get rid of this because we'll get to that. And so I'll run this again actually. So we've got our problem, call forward, and you'll see that my x's are 0 right now, but they're moving up a little bit because I gave it some sort of controls here. I said it's going to be 2. Actually 2 I think is too little. Let's make it 20, and that should move it quite a bit. So yeah, so you can see that it starts moving now. So see, it gets up to like 7. So this one's like 7 is, pi is like 3, so 7 is like, it's spinning like crazy, and you can probably kind of see it. If I went here, I like pasted it, you can see that it's just like accelerating into infinity. So we'll plot that again. It'll take a minute. I'm gonna take this time to reset the music because we don't want that. So that's gonna like start spinning. Actually, just stop spinning. Okay, so maybe it doesn't go to infinity. I thought 7 would. Well, yeah. Okay, it's not going to infinity. It's actually a bit underestimated. Well, let's make it 200 then. See this fly a little bit. That'll be fun. That might fly. Yeah, that's going crazy now. Might skip around though. I don't know. I'm gonna have a look. Yeah, okay, now it's flying. Okay, so we don't want this because that's kind of bad. What we really want is for it to go to the top and then stay there. So what we've done is we've taken our x's and y's, and then I'm saying, okay, here I want my x of n. This has to be pi, and then the velocity has to be 0, right? Because I don't want to be swinging. So here I'm gonna take. Therefore, what I'm gonna do is I'm gonna take this, I'm gonna square it and multiply it by a big number, and then I'm gonna take this. I'm gonna square that, and then I'm gonna multiply it by the same big number because I want both of these to happen. I'm gonna make that our loss. This is my loss, and this is not a very efficient way of doing this, but that's what we're doing. And then I'm gonna minimize our loss, and this is where our nice auto differentiation framework comes in, because you call forward and you see all of these have a tiny little gradient. Currently it's 0, that's why it's what I said tiny, 0 currently. They have a gradient object, and you can do basically basic gradient descent, where like for each x is gonna be the same minus some learning rate times the gradient of that loss. Say d loss, dx of I. And I don't have to worry about doing these calculations of gradients because we have our nice nice autodiff framework does this for us. And it takes, what it does is it takes every one of those x's and it builds our graph, right? So x's are connected to, we'll change the music again. X's are connected. If that's 1, nice. X and U, nice. That's what we want. Come on. Here, this goes to that, and this goes to that, because U pushes the pendulum, right? Here, swings up, and then that goes to x1, and then I can like copy this, and this is the graph that we get. That is exactly what I wanted to do. Hang on. Okay, there we go. So that's 2 now, and that's 1. So I've got all of these, and then eventually I will get our end states, and then that gets plugged in to this loss over here. That's the end. There we go. And then I also get the derivatives. They're also like, you can visualize them as different nodes in here, and they all get plugged in, and that gets summed, and then we can differentiate it. So I did this already, so let's try and see if I break it whilst I was showing things. I'm gonna restart so I don't get any seg faults. Run this. So yeah, so this is the physics of it. I've set the gravity to be something sensible, and then we have 50 of these, so 50 of these guys, and then we start at 0. Let's start at 0 because that's horrible. And then here's the target. We're at pi, and then this is the target. This is the square. This is that little bit here. So we run this. I actually don't need to learn forward. We've got some learning rates, 20,000 iterations. At every iteration I call 0 grad, and change the music. Hey, that is annoying. Right, there we go. That's better. So yeah, so we go 0 grad, forward, backwards, and then we iterate over 20,000 times, and we do learning rate times grad. So we're gonna code this now. This is gonna be pretty fast. So here, loss is 0 though. That doesn't look like what we wanted. Actual 0? Maybe. It is actual 0. Lovely. Okay, so let's do this and let's see what we get. Right. Yeah, okay, so this is pretty underwhelming, right? And the reason why it's underwhelming is because it's using a lot of U, and by that I mean these things are unconstrained, and that's kind of annoying because it means that realistically what I wanted to do is I wanted to swing and then go up, because that's more realistic, right? If I had enough power to just do this, then I mean I can, I guess, but it's more interesting if it doesn't have enough power, it kind of gets stuck here, so it has to go back and then up. So that's what we're gonna try and do. So a couple ways of doing it, and this is a cool one. So what I'm gonna say is I'm gonna take my my rectified linear unit and gonna add this to my big number. So here I'm gonna take this, I'll create a new field up here, and then I'm gonna say plus, big plus, and I'm gonna sum all of the u squareds. All of these u's are gonna get summed, but not just summed, but I'm gonna have some limit. So because it's a ReLU, it means that, right, ReLU of x, I'll actually show you the ReLU definition in here. Tensor, maybe not, maybe I have it in, okay, here, okay, so there's the ReLU. So it's, if it's less than 0, it's 0, and if it's not less than 0, then it's a number. That's the definition. So it's basically the max of 0 and the number, right? So if it's less than 0, then we get 0, and if it's greater than 0, then we just get the number. So here we actually do ReLU of u of I squared minus the limit, again squared. So basically, I get here from minus 50 to 50. So we're going to restart it, and we're going to run it all again. This is a lot harder than before, but so you can see here now we're just not like one-shotting this. It's taking us a while to get there. And there we go. So yeah, so it's taking us a while to get there. So you see here we start at like 50 and we go down, and then we try and counterbalance. This is still the same though, and I might actually replace the text. Now we're doing controls. Sweet. Alright, now we're doing controls. So still the same. You see it still has enough power. So the next question is, well, like, what happens if I don't give it enough power? So that's what we're going to do. Start with 20. I don't actually know if 20 is enough, but let's see what happens. Oh, I segfolded again. Yeah, that happens. It's because I wrote the auto differentiation framework, which... So yeah, here it's kind of stuck. Yeah, like it is not having a good time. Like this is, I mean, it is not having a good time. It is not learning to swing. Like it's still doing the same thing. Okay, so that's not fun. That's not what we're gonna do. So this was my idea going into this session. So the idea was like warm start this with just u squared. So basically, this means compute one trajectory that sort of looks like a swing up, and then initialize with limits and ReLU. And if we can get it like kind of right to start with, like maybe it swings up and then it sort of stops here, then the second problem can actually be solved. So that's what I'm going to try and do. So I'm going to change the text now and change the music. Okay, so warm start. Sweet. So after trying this for a while, I'm gonna get the music back up. I asked ChatGPT. I'm gonna neck myself because I said I wouldn't use AI, but here we are. To be fair, I didn't actually use what it told me to. Well, I used some of it. Okay, here it is. It's swinging now. I'm gonna get rid of this warm start idea because that's not what actually happened in the end. Fixed. It's fixed now. It's working. What ended up being the problem is that they just didn't have enough time to do it, and also my like cost that I did here with the clever ReLU and the limits, turns out that wasn't really necessary. Just needed to give it more time to swing up, you know. And yeah, I figured it out. There it is. It's now swinging, and that's fun. So not much changed, really. The main thing is we get rid of all of this. Actually, I said this to be something, but I have a feeling that doesn't even matter. We just changed the interval. We gave it more time. After trying for a while, I figured out that well, none of this had any effect really, and this wasn't even necessary, which is hilarious because I thought that was the clever bit in the formulation. But as you can see, like that, it's not really necessary. Even with the u squared, it just figures it out. Yeah, I mean this is even nicer actually. Now that we're not warm starting it from anything bad. So the warm starting idea didn't even really work. That's quite nice. Now we swing up. Yeah, very nice. And now we get to the top. That's lovely. That is. Our velocities are near 0. We do go kind of like this here, but I mean that's -6. It was like a minus what, 100 before. I think we got there. So in here, I guess we could just delete this bit because that's not necessary. Turns out long horizon, like enough time to swing. Stupid. Neck myself again. That was the solution. It's still we can still probably do some cool stuff. Like currently this is going to the left, so just to show some sort of worm starting. Like I think I can maybe make it go to the right instead, by giving it a different start here. It currently goes left and then right. I wonder if I just put a 10 here, whether that's gonna make it go the other way. I have a feeling it might not, and then that's different. No, I feel like that is different. Yeah. What? Oh, that now it just doesn't even respect my control limit. That's hilarious. We're gonna make this a lot smaller. Well, it goes to show you that worm starting does have an effect, right? So my idea wasn't totally wrong, but that's fine. Okay, so now we're going left still though, aren't we? Let's go to the negatives. Goes to -4. So one more nicking. I wanted to show worm start, but I had to ask ChatGPT again, hence the nicking. I wanted to show that if you had this at -5, it will go left and right. And we actually had this problem in one of the papers that we did years ago, where like you would go left and right on card pulls like this. I couldn't remember exactly how we solved this. And actually I can show you something here. So if you leave this like -5, and then I have my old, this is the fix, suspense, well, ruined, I guess. If we try the last formulation, right, which was target minus like this, so this squared, and then run it, right, I'll restart, run all. So this will give us one way. I give it a second. Oh, I crashed again. Gotta have to reload. VS Code, what are you doing to me? Okay, will you now run all? No? Now? Yeah, good. Go away. No using C++. Okay. So this is going left, yeah. So minus left. So this is going left. And now, what I can do is I can use this negative target instead of my target, right? Square it still, and then restart. Run all, and that should go to the other end. Okay. Or maybe it doesn't. Might have to neck myself again. Necking again. Oh. Huh. What? This was target minus. I mean, I suppose I could do it like this, right? That should change it as well, I presume. Okay, that looks better. Ah, maybe this is what it really doesn't like. And then make this -pi. Okay. Yeah, okay, so then that goes the other way. See, it changed the controls. Should be able to flip it like this. Yeah, so now it goes the other way. So now it goes left. So what was happening really is that, like, what we're doing here is realistically minus some target. And this changes, like I'll go here, x minus target and target minus x. Doesn't matter when squared. Yes matters when gradient. Okay, so it matters when you differentiate that, which way you go. In the square it doesn't matter, right, in the end. But what you can do is you can realize, which I didn't until ChatGPT told me, that the cosine of this, yeah, works as well. And this is actually, now that I remember this, I remember that this is how we solve the problem here as well. It's that cosine of 0 is 1, right? And then cosine of pi should be 0, unless I have to neck myself again. Minus 1, sorry, minus 1. Cosine of pi over 2 is 0. Cosine of pi is minus 1. So then 1 plus cosine of pi should be 0. And we want our cost to be 0 there. So we just, instead of doing any of this shenanigans, we say my cost is just the cosine plus 1. That. And then this, I can remove this. I don't even need a target here, really. And I suppose this is another way of formulating that, so I can get rid of that. Comment it out. And controls are 0, so I'll restart it. So here, numerical noise and, you know, wet. What have I done? Maybe there is no numerical noise. Maybe I do actually need to seed it in this case. Imagine that. This is what I was going to do. I do need to seed it. Lovely. We don't have numerical noise. This is the good stuff. I will end on this. I was deciding whether to put that in the video or not. Okay, so now this is left, right, independent. Okay, important. And if U's are 0, doesn't work. So now we're going to demonstrate warm start. We're going to demonstrate warm start by setting these to 2. Actually, I think I can even say like something like this. It doesn't really matter. Like something very small, and then run it. And maybe it can't be that small, huh? Maybe I'm getting ahead of myself. I'll set it to 2. Okay. Start run all, and I crashed VS Code server again. This is lovely. I clicked too quick for VS Code. So when I start it going there, it's going to go one way, and then when I initialize it going the other way, it's going to go the other way. And this is hopefully what happens now. Okay, this is running. Didn't make this up. Hands off the keyboard. Okay. So now we're going left, just like before. Give the animation a minute. Boom. Okay, so left, then right. We're not quite at the top, but we can. That's the weights thing. We can definitely fix that in post, as they say. No, we can just up the weights here. If we up this weight, that's how that gets solved. But right now we're not touching other stuff. Okay, so now I've set this to -2. So now hopefully this means we go the other way. And there we go. Okay, this goes the other way. Okay, we'll see it in a second. Okay, boom, boom. And that's yes, warm start. That's the effect of it, and it does have an effect. I knew it has an effect. It just took me an hour to get there, and I had to neck myself for using AI. But yeah, that's it. I'm gonna clean this up, commit it, and link it. Hopefully next time it'll be easier. I think next time I'll do either. I'll just write this down. Either quadcopter, or maybe cartball. We don't know. One of them for next time. Adios.